That's the hypotenuse?
That's correct. C. Yes, ma'am. Why did they say C instead of H? I don't know.
Is that only for right triangles?
That's only for right triangles. However, right triangles are used all the time. And this actually has a real-life application, which we will get to in one moment. But before we do that, let's try something else here. Let's say, for example, this here is 13, and this here is 5. And I want to know what this side is. I can still use the Pythagorean theorem. How do I do that? I always start with my equation, which is what, sir?
Something A.
Something A?
A2.
A2?
A squared. A squared.
A squared. Plus
5 squared.
Plus B squared. Good.
Equals to C.
Equals C squared. We always write the formula out first. Why do we write it? You say, Mr. Vassal, I already know the formula. A squared plus B squared equals C squared. You told me, Mr. Vassal, that I would know in my sleep, and I do. My deepest and darkest nightmares, that formula comes, and I see it. Well, yes, I understand that, but, hang on, but we always write it down because if I make a mistake somewhere along the line, I don't want the mistake to be because I wrote the formula down wrong. Write the formula down right, then insert the numbers. Now, in this instance, which letter is missing? Yes, ma'am.
A or B.
A or B. Good. It could be A or B. We'll just say B. Okay? So, let's put my numbers in. 5 is what? Is it A or C?
A.
So I have 5 squared plus B squared equals 13 squared. Now, what is 5 squared? Yes, sir?
25.
25. Wow, didn't I ask you that last time? 25 plus B squared. What's 13 squared? Shanna? Now, see, we should know this. 10 squared is 100. 11 squared is 121. 169. Good. Now, I want to get B squared by itself, so I subtract 25. Get out of my house. And I have B squared equals what? What's 169 minus 25? Jisoo? 144. And when I find the square root of both sides, what does B equal? Someone knew. Rosa, what's the square root of 144?
I wasn't here.
Well, yeah, but you still should know. What times what equals 144? You wonder? I wonder too. Let's see. Arnell, do you know? What's the square root of 144? Alright, we need to memorize these. Yes, sir. 12 is correct. So B here equals 12. Everyone needs to memorize all the square roots. Now, you should know most of them by now. But you need to know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7, 49, 8 times 8, 64, 9 times 9,
81,
10 times 10, 11 times 11, 121, 12 times 12,
144,
13 times 13,
169,
14 squared,
196,
196, 15 squared,
225,
225, 16 squared, huh? 256, 17 squared,
289,
289, 18 squared, 324. Did you write in your notes? That's what you should do. 19 squared,
361,
361, 20 squared,
100,
400, 235 squared. Don't worry about that. Maybe that's next year. Ma'am.
What's the pattern?
It's plus 2, well, plus 1, plus 2, plus 3, plus 4, plus, I'm sorry, plus 1, plus 3, plus 5, plus 7, plus 9.
So,
But you won't be able to recognize the pattern when you have a giant number. You just need to have it memorized up to 20. Now, what if my answer here, though, was, let's do one more. Let's say, for example, this is 3, and this is 6. I put my formula up here. A squared plus B squared equals C squared. So I have 3 squared plus 6 squared equals C squared. 9 plus 36 equals C squared. 45 equals C squared. C equals the square root of 45. What is the square root of 45? Yes, ma'am. Samir. Well, yes, we'll pull up our little calculator. 45 is square root of 6.7. Now you should know that, right?
Yeah.
No. You don't need to know it. So if it's not a perfect square root, then you can just leave your answer so that it looks like this. Now, I'm going to show you how to reduce those later, but for right now, you can just say the square root of 45, and that's your answer. But you would not say the square root of 64. Instead of saying that, you would say what? 8. Well, usually plus or minus 8, but because this is a geometry problem, we put 8. Now, again, Mr. Fessel, who uses the Pythagorean theorem in real life? Is this used at all? Why, yes, my friends, it is. Let's say, and let's see, we'll go here, blobs, I don't want blob. I want,
What's a blob?
it's just a big blob. Okay, let's say I have this Viking here. And he's wondering how big he is. Okay? But he's a giant Viking, okay? This is the story of Jack and the Beanstalk. So here I have this giant Viking. And I want to know how tall this Viking is. But I'm afraid to go ask him. Because if I ask him, there's a very real possibility that he will eat me. And I don't like being eaten. So I want to find out how tall he is. And so what I do is, I measure how far I am from him. Then I throw a rope up to his hand. He says, what are you doing? I say, nothing. I pull the rope down. I measure the rope. I measure how far I was from him. And I find how tall he was. And you say, oh, is that really possible? Well, actually, that's what scientists do. They use the Pythagorean theorem partially to find out how far a star is away. Is it possible to find out how far a star is away from us? By measuring it with a tape measure.
No.
What do? Stick the tape measure in a rocket ship, you shoot it off and you hold it. But these things are billions and trillions and quadrillions and quintillions of miles away. Vast distances away. I don't have that long of a tape measure. And so the only way to measure them is they watch how the stars move, they see how far it moves on Earth, they find right angles, and they use what we call trigonometry to figure out the distance. Now, trigonometry is not a class that we're taking now, but the Pythagorean theorem is part of the beginning of trigonometry. Because using triangles, we can find out all kinds of distances. And using triangles, they can find, for example, how far to go across a river to build a bridge, or how tall a building needs to be before the wind will knock it over, and how big the base needs to be. So the Pythagorean theorem is really useful. You probably won't run across a giant Viking who will eat you if you measure his height. But there will be all kinds of instances where using the Pythagorean theorem could save your life. Maybe not save your life, but you'll be working in many jobs where using the Pythagorean theorem will be very handy. Samir, with your little handy book, what?
Can we measure you right now?
Can you measure me? Yeah. But I'm going to tell you how tall I am.
But you'll eat us.
No, not today.
He's saving room for soup.
Not today. So that's basically today's lesson. It's very simple. If you know A and B, you can find C. If you know C and B, you can find A. Let me give you one, and you guys can work on it. I will draw a beautiful triangle here. And I'll give you two of the sides, and work it on your paper. And let's see. We'll make this side 4, and we'll make this side 8. Tell me what the missing side is. Start working on it. Make sure you write the formula. Is it a whole number? We're about to find out.
No, is it a homework?
No, this is classwork.